IoT security is the technology segment focused on safeguarding connected devices and networks in the Internet of Things. IoT involves adding Internet connectivity to a system of interrelated computing devices, mechanical and digital machines, objects, animals and/or people. What is IoT security? IoT security refers to the methods of protection used to secure Internet-connected or network-based devices. The term IoT is incredibly broad, and with the technology continuing to evolve, the term has only become broader. From watches to thermostats to video game consoles, nearly every technological device has the ability to interact with the Internet, or other devices, in some capacity. IoT security is the family of techniques, strategies and tools used to protect these devices from becoming compromised. Ironically, it is the connectivity inherent to IoT that makes these devices increasingly vulnerable to cyber attacks. Because IoT is so broad, IoT security is even broader. This has resulted in a variety of methodologies falling under the umbrella of IoT security. Application Program Interface, API, security, public key infrastructure, PKI, authentication and network security are just a few of the methods IT leaders can use to combat the growing threat of cybercrime and cyberterrorism rooted in vulnerable IoT devices. IoT security issues and challenges. The more ways for devices to be able to connect to each other, the more ways threat actors can intercept them. Protocols like HTTP, Hypertext Transfer Protocol, and API are just a few of the channels that IoT devices rely on that hackers can intercept. Below are a few of the IoT security challenges that continue to threaten the financial safety of both individuals and organizations. 1. Remote exposure. Unlike other technologies, IoT devices have a particularly large attack surface due to their Internet-supported connectivity. While this accessibility is extremely valuable, it also grants hackers the opportunity to interact with devices remotely. 2. Lack of industry foresight. Industries such as automotive and healthcare have recently expanded their selection of IoT devices to become more productive and cost-efficient. This digital revolution, however, has also resulted in a greater technological dependence than ever before. 3. Resource constraints. Not all IoT devices have the computing power to integrate sophisticated firewalls or antivirus software. Some barely have the ability to connect to other devices. IoT devices that have adopted Bluetooth technology, for example, have suffered from a recent wave of data breaches. The automotive industry, once again, has been one of the markets hurt the most. In 2020, a cybersecurity expert hacked a Tesla Model X in less than 90 seconds by taking advantage of a massive Bluetooth vulnerability. Other cars that rely on fob, wireless, keys to open and start their cars have experienced attacks for similar reasons. Threat actors have found a way to scan and replicate the interface of these fob-style keys to steal the associated vehicles without so much as triggering an alarm. If technologically advanced machinery like a Tesla is vulnerable to an IoT data breach, then so is any other smart device. How to protect IoT systems and devices. Here are a few of the IoT security measures that enterprises can use to improve their data protection protocols. 1. Introduce IoT security during the design phase. Of the IoT security issues discussed, most can be overcome by better preparation, particularly during the research and development process at the start of any consumer, enterprise or industrial-based IoT device development. Enabling security by default is critical, as well as providing the most recent operating systems and using secure hardware. 2. PKI and digital certificates. PKI is an excellent way to secure the client-server connections between multiple network devices. Using a two-key asymmetric cryptosystem, PKI is able to facilitate the encryption and decryption of private messages and interactions using digital certificates. 3. Network security. Networks provide a huge opportunity for threat actors to remotely control others' IoT devices. Because networks involve both digital and physical components, on-premises IoT security should address both types of access points. Protecting an IoT network includes ensuring port security, disabling port forwarding and never opening ports when not needed, using anti-malware, firewalls and intrusion detection systems/intrusion prevention systems, blocking unauthorized IP, Internet Protocol, addresses, and ensuring systems are patched and up to date. 4. API security. APIs are the backbone of most sophisticated websites. They allow travel agencies, for example, to aggregate flight information from multiple airlines into one location. Unfortunately, hackers can compromise these channels of communication, making API security necessary for protecting the integrity of data being sent from IoT devices to back-end systems and ensuring only authorized devices, developers and apps communicate with APIs. Additional IoT security methods. Other ways to implement IoT security include network access control, segmentation, security gateways, patch management/continuous software updates, training, integrating teams, consumer education and more.